Good morning. So welcome again to this webinar around steel framework design with advanced design. I don't know how many of you are familiar with this software. This is the flagship structural analysis software of Graitec and can be used for the design of timber, concrete, and steel structures, and also linking with many softwares like Revit, Advanced Steel, AutoCAD. It allows for a easy BIM workflow. So my name is Sara Santana Herrera, and I work as an application specialist on the structures team at Graitec UK, so the UK branch. We are located in many countries like France, Italy, Poland, Romania, and so on. I am a structural engineer and I have experience in the nuclear building industry, also steel industry, and the software like Advanced Design and some of the other softwares from Autodesk and ANSYS and so on. So today we will cover the topic of designing a steel framework with Advanced Design for around 40-45 minutes. And at the end of the session, there will be a Q&A session, so you can ask me anything you want. If we don't have enough time to cover all the questions, you can contact me to my email, sarah.santana-herrera@graitec.com, or you can contact me via LinkedIn. So today we will use Advanced Design as our main structural analysis and design tool. In this software, we will model structure from scratch. So I will show you some of the tools we have to sketch a structure, and also a tool we have to speed up this process, which allows for the creation of, let's say, modular or typical steel structures. Then we will look at how to create loads and combinations, and also how to set the design parameters like buckling, lateral torsional buckling, how to activate warping and imperfections, and some of the other design parameters. Then we will look at how to understand the results, so using the post-processing tools and creating calculation reports. And then we will design a couple of steel connections using our BIM Designers module. So BIM Designers is a module that can be used with many software. So from Advanced Design, from Revit, from Advanced Steel, but also as a standalone product. We have two series of BIM Designers modules. So the concrete series, which encompasses a beam, column, foundation, wall, and slab module, and then the steel series, which can be used in Advanced Steel or Advanced Design. So from Advanced Design, we can use the steel connection BIM Designers module, and also the structural designer. Okay, and then the stairs and railings can be used from Advanced Steel. Okay. So again, as I said, if you have any questions at the end of the webinar, you can send them to me via email or contact me via LinkedIn. Okay, so let's start the webinar. First, when you open the Advanced Design software, so I'm using today 2021 release, which was officially released the 25th of May, so it's quite new. And we have implemented many new features with regards to steel and concrete design, but also overall structure analysis. So from the starting page, we have the create option in here. And then we have also the learn section. So from this learn section, you can find some resources to have some practice with the software. So all is linked to YouTube videos. Okay, concrete design, meshing, post-processing, calculation reports, and so on. Then we have also a section with all the news with regards to advanced design and other Graitec products. Documentation around advanced design, so what is new in 2021, starting guide, user guide, and so on. A knowledge base with articles with technical topics. And then we have also some social posts in here. Okay, now from the create section, I will set my, okay, that's okay. I will just double check that I have the correct standards in here. So you can see we are working with Eurocode. So this offer allows us to work with Eurocodes and some local standards, for example, for the US, for Canada, for Italy. But very important to note, it is not able to work with British standards. So Eurocodes plus national annexes for the UK are added in here. Okay, so I'm happy with this configuration. As I said, we can also import a file from Revit, for example, or from Advanced Steel. And this will be done via our BIM Connect tool. And we can use either GTCX files or SMLX files to perform this BIM import, export, and synchronization between models. Right, so I will start with a new project. So to briefly show you some of the tools we have to sketch. And after I will continue working with an already created model. Okay, so I will just give a name to this project, Steel Framework. And then we can choose if we want to work in plane mode, grid mode, or 3D mode. I will select 3D mode, bend and rigid structure S275, and I will select this column as my default cross section. Okay, and then you can see the interface is quite intuitive. We have all the menus in here going from the modeling to the analysis to the post-processing of results, documents, BIM links like DXF, IFC, SDNF, and also Graitec BIM for the GTCX files and SMLX files. Manage tab where you can contact support. We can access also Graitec Advantage for documents, for new releases, for technical articles, and so on. And then we have the design menu. This one, we will see it in action when I start doing the steel connection design. Okay, so now from the home menu, I have a project browser in here in which I will find all the elements created in the model. So I'll start by creating a linear element. You can see I have on the right side a properties table. Still, the cross-section I did input as my default cross-section. And then we have many other parameters like haunches, orientation, releases. We can create total releases, elastic releases based on rotational or translational stiffness. Also, we have some meshing parameters for specific elements, transfer of loads from wind and snow loads, and then we have all the design parameters in here. Okay, so I will start by creating a simple column in here, let's say 6 meters, and then I can copy this one to the other side using one of the cut functions. Okay, so let's say 10 meters away. Okay, same height. I can also change the height of this one like this, 2 meters more. That's perfect. And then I can start drawing all the other elements. So for example, the rafter in here, I can select another cross section from the library. For example, universal beam. Let's select 356. Okay, press enter to accept, and then just draw the rafter. So we can go via the graphic area, use the grid, use the snap points, or we can also use the command line. You can see as soon as I click on one of these elements, my command line becomes active, so I can just specify a vector. So let's say I want to create a gable post in here. Okay, so what I will do, I'll put the coordinates and they will appear in the command line, and then the gable post will be drawn. Okay, so I'll put 5 space 0. You can see it appears in there, and then I can either snap to the mid-span of this rafter or use again the command line. So I think it's easier just to snap, sorry. And then I can change the cross section of this gable post. Let's say give it a UC 203, this one. Okay, so, and then I can start copying this frame many times. So again, using the copy function and specifying a vector in here. Okay, so let's say 5 meters, and I want to copy it 5 times. I can switch to a 3D view, so it becomes easier to visualize. So now I have all my other frames created. I will switch to a top view and then change my work plane. You can see now you can start drawing all the purlins or side rails and other secondary members. Okay, so let's say I want to use this one, UB. Okay, and then just snap in here like this. And so on. We also have some other tools like the symmetries. Let's say if I want to copy this framework to this side of the graphic area to make it symmetric, I just have to select all and then go symmetries. I'll use this point as reference point, then specify the plane. Okay, so now we have a framework in a matter of seconds, actually. Right, so this is from the sketching point of view. We can also add supports from here. You can see I have supports, so I can just select the type of support I want to use. Could be rigid, could be elastic if I want to input damping, seismic damping, or stiffness. And then in this case, I can also specify a soil layers. Okay, so if I go here, automatic, and then click on definition, I can add a soil layer, specify a thickness, and then the software will automatically calculate the vertical stiffness based on these soil layers. So I just click OK. You can see vertical stiffness has been calculated. Okay, and this works for linear as well and area supports. Okay, so let's say I want to create rigid support. This time it will be fixed. I just have to snap to the bottom of each column, or I can also select some of the columns and then right click, support on selection, rigid, and just make sure it's fixed and then go OK. Right, so I won't spend too much time in this sketching part because I want also to show you some of the design parameters, how to use them, how to activate them, and so on. So what I will do now There is also a way of creating a structure from scratch without drawing each member and adding all the cross sections and so on. So we can use the default structure, or structure designer is actually the same thing. And from here you can see there is a library of different types of structures, and then you can customize the spacing, number of bays, the cross section of the rafters, of the purlins, of the side rails, of the gable posts, columns, anything. You can also create platforms, you can create openings, you can add levels. It's actually quite useful. Okay, there will be a webinar around this specific tool next week, so I won't spend more time on this now. And another way of creating a structure from scratch is also importing a DXF file, sorry. So from the bin menu, DXF, and you can just import the file. We have a tool in here to convert lines either to linear elements or to plan elements. So if you're used to work with an AutoCAD model, this could be a fast way of creating your structure in Advanced Design. Right, so I'll close this model and I will work with another one I have already here. You can see I have some columns, some rafters. I have displayed in here the different cross sections. And if I expand on the structure branch, you will see all the members that I have in this model. So non-structural, like points, and also structural elements will be listed in here. So one of the first steps to design a framework is, of course, we need to add loads. And some of the loads are the climatic loads. So very important for steel framework design is to have correct wind and snow loads. You can notice I have already my supports created, so I don't need to create them at the moment. So I can go right-click loading, create several case families, and you can see the list of available load cases we have in Advanced Design. So I will add a dead load case, a live load case, and then snow and wind. Dead load case automatically takes into account the self-weight. I will add some live loads just on the roof of this building. Okay, so for this I will create an area load. Right click, create a load, area load, okay, and then I will put minus 2.5 kilonewtons per square meter and just draw the load on top of the purlins. Okay, I have my load in here. I can select it the same way I select any element from the graphic area, and then I have all the properties on the right side of the window. Okay, now I will create some load areas, not the same thing as area loads. Okay, so load areas are actually panels to distribute and generate wind and snow loads. They can also be used for some other things like creating diaphragms and so on, but I would just stick to the climatic loads today. So for this, go load area and then start drawing the load area as you would for any area actually. Okay, and you can see now I have a load area here. I can select the span direction depending on how I want my building to behave. And you can do the same thing for the other faces. So the building needs to be completely closed with this load area so we can automatically generate the climatic loads. So yes, we can generate these climatic loads automatically in Advanced Design. You will see it in a few seconds. And it's a very useful tool because we don't need to go and create the loads one by one. Okay, so another load area in here. This time I wanted to span towards the purlins. Okay, and the last one on the other side. That's perfect. And then just change the span direction. Great. now my building has all the load areas it needs. I can go to the snow load case, and you can see on the right side we have many parameters to correctly input our let's say location for the snow. So we have in here parameters, typical value. I can click in here and select from the map, okay, depending on my location. Let's say I want this one, and then you can see snow load and exceptional snow load are updated. I also I will also input the altitude, let's say 100 meters above the sea level. And then we have also some situations like exceptional snowfall and accumulation. Again, this is according to Eurocode 1 and the British annexes. Now, to generate my wind loads, nothing is easy. Just right click automatic generation, and you can see I have now 3 snow load cases. So if I want to display them graphically, I can isolate these loads. Okay, I click isolate, and then I will hide load areas. And you can see minus 0.4. That's the value of my snow load in here. Okay, and it's just there. Now I can also take a look at the other ones. Okay, and you can see the value has changed, and in here as well. So we have 3 snow load cases. Now I will create my wind load cases following exactly the same process. So first I will hide loads, then I'll go wind load case, and you can see on the right side we have all the properties for this wind generator in here, and then we have wind directions. At the moment I have all of them are active. Okay, so the software will calculate, will generate loads for all the directions, and then I can select wind speed region as I did before, and then you can see wind speed and pressure are updated, also direction coefficient and some other parameters. In here I will put again 100 meters for the altitude, and some more parameters for side effect, dynamic effect, and so on. Right, so now I will generate my wind loads, automatic generation, and I will isolate the first case, display the loads, and you can see all the areas. So I just have to select one of them. You can see on the right side, it's region D according to Eurocode. I have CPE and CPI values, and you just have to select another one and you will see how this changes, and we have also the actual load in the table. Quite an easy task to do. Of course, if you want to go manually, we can just create a case, add a case in here. You can see I have possibility of adding a load. It could be a point linear area load, but why would I do this if I have an automatic generator? Okay, now I have to create combinations before I proceed with steel design. So combinations, we have a quite easy tool, which is a simplify combinations tool. I just have to set my predominant action. In this case, I will say it's snow loads, and then generate yes, and you will see all the combinations have been created. Of course, this is based on the amount of wind and snow load cases. Now, a few things before I launch this analysis. For the steel design, we have global settings and we have local settings. Okay, so for the global settings, I have in here verification using cross-section strength and element stability. If I need to add imperfections, I have the options in here: global sway imperfections, local bow imperfections, and also second order analysis. Okay. I also have optimization based on a maximum utilization ratio, and this can be done by element, by cross-section, or also by name and per system. I can sort profiles by weight, So I will always have the lightest one. And this will be using envelope criterion. Okay, so using both deflection, strength, and stability utilization ratios. Some buckling parameters as well. Okay, different methods, and also calculation sequence. So if we want to perform a steel design based on both strength and stability, we need to check this calculate buckling is active and verify deflections and calculate shapes. Okay, this is for the global parameters. Now, if I select any of the members, any of these steel elements, for example, this column, you will see in the properties table at the bottom, I have a design section. So in design section, I have many parameters like manufacturing quality for the steel. I also have the cross-section class. At the moment, the software will do it automatically. I can also select if I want it to be class 1, 2, 3, or 4. Execution class type. And also we have the deflections calculation, okay, with different limits. We have the buckling lengths, okay, at the moment they are set as automatic. We have lateral torsional buckling length, automatic as well. Okay, I will show you how to change a little bit these parameters. And then we can activate imperfections, global and local imperfections for the whole, for the column and for the rafters and for any other elements in the structure. And I can also perform fine verification for any of these elements. So first, I will just run the calculation as it is without changing any parameters, and then I will show you how to do this. Okay, so go analysis, and then steel design. Because we have many wind load cases, this could take a few minutes. I hope it won't be too long. And you will see in the results menu. So as soon as the calculation is finished, the software will jump to the results menu, and from there we will be able to post-process the FEM results and also the steel design results. And you can see in the project browser, I have all my load cases and combinations listed in here, okay? So this project browser is quite useful to have a very organized model and know what I have inside the model. Okay, so calculation is finished. You can see now I am in the results menu. FEM results toolbar is active and steel design results toolbar as well. So from the FEM results, you can post-process displacement, for example, for my self-weight or any combination that you want to post-process. Okay. I can also post-process the bending moments, let's say for a ULS combination. Okay, so let's say one of these, and then bending moment. Okay. Also, I can display the supports, the reactional supports, so vertical reactions in here. Okay. Stresses as well. Okay. And I can play with the size of the diagrams using this this small tool in here. Okay. I can also activate values on diagrams like this, and you can see all the small values appearing, and you can also control the size of them in here. Okay. Now I can also display the steel design results. So for example, strength, I want to take a look at my utilization ratio for bending moment. You can see in some areas I have more than 100%. For the axial force, the bracings are working fine, maximum of 23%. And then I can also take a look at the, for example, buckling length, okay, slenderness, and also I can take a look at the deflections, okay, and so on. Lateral torsional buckling as well. I have the parameters in here. So you can see some of the members have are working beyond their capacity, which means I have to redesign them. So what I will do, I will select one of the members. So it will be easier for me to display the profiles. And then I'll just clear results in here. Another way of post-processing the result is selecting any of the elements in the model and then selecting this document in here. And you can see a detailed list of different verifications of deflection, cross-section strength based on tension, compression, shear, and shear force and bending moment, and also all the stability results. So you can see here I have quite big buckling lengths, and this can be corrected, or let's say you can define more accurate buckling lengths if you go down in the design section with the column selected, and then you go in here, buckling, and let's say I want to consider I have a side rail in here which will reduce my buckling length. I just click in here and I can select element ratio. I want to consider my side rail mid height, then OK, and I can perform calculation and design of this column only. So we have the possibility of doing this in the 2021 release, calculation on selection only, which is quite useful because we can iterate among different solutions before we actually consider that our design is finished. So now with the column selected, I will go again and select in the document. You can see now I have my updated buckling length. I can also play with the restraints, for example, for this column as well. At the moment, I have the total height of the column as my lateral torsional buckling length, both for upper and lower flanges. But if I have a side rail in here, of course, this will also contribute to the lateral torsional buckling positively. So I just have to create a restraint in here. So I will start by displaying the restraints. So you can see we have restraints both at the top and bottom nodes. Okay, so end and beginning points of the column. And I want to add one in here at the mid height. So I will go and expand lateral torsional buckling, click in here. And I want to consider the side railing located at the lower flange. So graphical definition, click midpoint. And then you can see in here, you can select if this is a pin, a fixed, or also a continuous restraint. Now click OK, and I will launch again the steel design only for this column. Yes, only this selection. Now it is updated. I can go in here, and you can see now for the lower flange, my lateral torsional buckling length has been updated. Right. We also have an advanced stability tool. So if I select, for example, this purlin, I have in here the advanced stability tool. So let's just take a quick look in here and see what we have. So again, we can add intermediate restraints for these members. Okay, so this advanced stability tool will account for warping and Also, it will account for loads offset, so you can input a load position at any of these points. Imperfections, and if you have also a cladding, continuous cladding, you can create springs with this tool to account for this restraint, okay, continuous restraint. So the same way as I did for the lateral torsional buckling, you just have to add a new point in here, specify the position, and then you can see we have direction and type of restraint. So if I go in here, you can see translation, X, Y, Z. I can select fix, free, automatic based on the internal forces of the structure and the, let's say, global stiffness of the structure. And then if I select elastic, I can input a rotational or translational stiffness. So we have also rotations, X, Y, Z, and we have the warping in here. So this advanced stability tool accounts for second order effects, and it is very useful mainly for monosymmetric sections, which are quite prone to warping. Right, so I don't want to launch the calculation now. Right now, before I start with the steel connection design, another way of post-processing the results is going via the documents, generate a new report, and then in here you will see we have tables, steel analysis with all the data and the results. Okay, so the flexion verification, buckling coefficient details, shape sheets, the ones we have in here. So the shape sheet is actually this document which has details of the different verifications performed for a single element. So if I click in here, I will have a document only for this column. But if you go to the documents menu, you have the option of adding to the report this type of results for all the members in the model. Okay, I also have maximum deflections, I have global imperfections, so imperfections actually are calculated as equivalent horizontal loads, and also details of my fire strength and stability and so on. Okay, we also have a tool which is called the super element. So for example, for this rafter, this is a continuous rafter. And I will just take a look at the verifications in here. So you can see it's taking into account the whole length of the rafter, but then for the stability is also taking the whole length, which is not ideal. So what I would do is I will split this rafter in three and then activate the super element so the deflection is calculated for the whole length. So for this, I will just go in here and select select the rafter, then click on subdivide, 3 subdivisions, and then you can see I have 3 subdivisions in here. Now I will group these elements in a super element. Okay, and you can see now in the properties table I have 3 elements as super elements. I will now activate the super element deflection. Okay, and rerun the analysis. Okay, because I did perform a geometrical change, I have to run the analysis and design from scratch. So you will see the strong point of this super element is that you can calculate the deflection based on the total length and position of, for example, in here the gable post will be considered to create intermittent restraints for the rafter because you did split the rafter in 3. So we have quite a versatile option with this super element. So just before I start drawing, modeling the connections, in beam designers, we have standard connections according to the Euro codes. Okay, so mainly base plates, beam column connections, splices, tube connections for the bracings, and so on. Right, so my calculation is finished, and I will now select the rafter. Okay, goes to element selection, select the rafter, and you will see now I will display the verification. So I have better lateral torsion and buckling lengths in here because I'm considering each portion of the rafter. But then for the deflection, I still have a verification based on the total length. Okay, right. Now, the connection design. We have a library of connections in here: base plates, splices, beam to column connection, also pin connections with angles, and so on. So I will create a connection in here between this column and this rafter. Quite a simple task. Click on the connection, sorry, then select the column, select the beam, and a small symbol appears, this brown rectangle, and it's telling me in the properties table the properties of this connection. So element 1 is the column, element number 3 is the beam, length of the beam, and so on. So material, thickness, and so on. Right, so now I will perform again the FE analysis to have the internal forces for this connection. And you will see in 2 minutes I will design this connection. It's quite quick with our beam designers tool. Okay, so my FE calculation is finished. Now I just have to go to design. You can see on top of the list my connection. I will open it, and you will see now we will be working in the design menu of advanced design. So this is actually the beam designers module for steel connections. Okay, so you can see now the interface has changed. I have a few new tools on the at the top of the graphic area, and very soon I will have the views of this connection. Okay, now I can see inside loads and combinations. I have all the loads coming from advanced design. I have some options in here in the geometry tool to create, for example, stiffeners, to create chamfers for the stiffeners, or upper lower stiffeners for columns, beam stiffeners as well, web stiffeners, and so on. Plates, I have an end plate in here, but I can also add shim plates, cap plates, bolts position, holes, and also their definition, so diameter and type. And then I have materials, and then I have welds. I'll just use the default values in here. We have also some design settings, and we have also the possibility of launching the design of this connection. Okay, so software is telling me, okay, there are a few warnings, mainly with regards to the welds, also the slenderness limit, and I have in the calculation results tab the verification, so a summary of all the verifications performed for this connection. So these warnings are mainly for the constructive dispositions, You can also issue a drawing based on this design. So quite a simple drawing with an elevation and a section. And I can also create a report. So this time I will just issue a quite simple, simplified report. Okay, and then generate report. If you select a detailed report, you will have all the reference to the sections and chapters of the URL code. Okay, so just while my report is generated, if you have any questions, you can start writing them in the chat. Okay, I think. Okay, I have a question from my one, I think. Can we get a presentation at the end or a tutorial to follow what we went through today? Normally these webinars are recorded, so they should be available in our website maybe in a week or so. So yeah, I can send you the link once it has been uploaded to our website. Anyone else has any questions while we wait for this report to be generated? Again, as I said, if you have any comments or any questions, even after the webinar finishes, you can contact me to my email, okay, in here, or via LinkedIn. So don't hesitate to do so. I think report is now finished. Yeah. Okay, so this is the report. As I said, this one is a simplified version. So I only have a summary of all the verifications performed and my rotational stiffness. So this can be then used to update the model and make it more accurate. Okay, so that's my simplified report. And as I said, you also have the drawing, and as soon as I close this module, any changes will be updated in the global model. Okay. So I hope you did enjoy the webinar. It was quite fast-paced, I think, to cover most of the topics around steel design. And yeah, so if you have any questions again, or you can start closing the webinar. If you're not familiar with the software and you are interested in knowing more, either you would like to have a demo of the software or a training or so on, you can visit our corporate website, www.graitec.com, our UK website as well, graitec.co.uk, or contact your local representative. Yeah, thanks for attending and have a nice afternoon. and see you soon on our next series of webinars. Bye bye.